Hello, I am very excited about today's video as this is my first foray into investigative journalism. Specifically, we will be taking a look at the KEEPFILTERS DAX functions and investigating whether it does indeed provide better performance than regular filter functions in DAX. You might be asking yourself, why would I pick this topic? And it's actually kind of interesting. Microsoft has a site dedicated to Power BI guidance, and you just need to Google Power BI guidance and you will find this site, and it's actually a very good site. It has a lot of very good advice around many different topics, from general Power BI guidance, from optimization, white papers perspective, to Power Query and transformation and shaping perspective, data modeling, reporting, and others. So there's a lot of different topics that this guide covers, and the one that I decided to drill into today is this one. The title of the guidance says DAX, avoid using filter as filter argument. It takes, good news, only 2 minutes to read, and effectively what it says is that when you write a filter function, or when you write a calculation that uses a filter function, for example here, calculate the red sales, you calculate sales where product is equal to red. Microsoft claims that this is not very performant, and a better way to do this is to use KEEPFILTERS function. So as you can see, very similar syntax. We're still using calculate, we're calculating the same measures, but instead of using a filter functions, we're saying KEEPFILTERS, and we specify the filter condition. Also, it's important to know that there is a bunch of limitations in KEEPFILTERS. I'm not going to be going into those limitations in this video. All I'm going to try to do is see whether KEEPFILTERS does indeed provide a gain in performance relative to using a normal filter function. So let's take a look at the data set that we will be using for our investigative reporting. So I happen to have a pretty decent data set. At least I think that should be pretty interesting for this purpose. It's fairly large. It has 863.7 million rows. In terms of the layout, it's a very standard sales retail data set. So we have a sales table that houses sales for our unit across multiple stores for different products. So here's my time dimension, store, item is the product. And then account table has the kind of metric that we're keeping in sales, whether it's units or dollars. And I've created a report, and in this report we're going to be doing some performance measurements and trying to figure out whether filter does run slower than KEEPFILTER functions. And as you can see, there is again 863 million rows, so roughly 487 million rows for 2011 and 327 million rows for 2012. And let's take a look at the measures that I've created to test this performance. So what I've done here, I've created 4 grids or matrix controls, as you can see. On the left, I have, they're all set up exactly the same way. I mean, each row, the top row is set up very similar to each other, and then the bottom row, these two are set up very similar to each other. The only difference is in the left side, I'm using slow measures, i.e. using filter functions, and on the right, I'm using fast measures, or measures that are using KEEPFILTERS functions. So let's take a look at what I mean. So for example, let's take a look at a sales measure. So we have a sales slow, and what it does, it calculates a sum of amount, and the amount for accounts where account is dollars. And that's different from unit slow, where we will be calculating sales amount, but the count will be units. So again, the reason they're slow is because this syntax, even though I'm not explicitly spelling out filter, effectively is very similar to this syntax right here. So let's go back to our Power BI. And now let's take a look at our fast functions. So fast functions look a little bit different. So the fast sales will look very similar to begin with, calculate some sales amount, but now instead of doing a filter, we're going to use KEEPFILTERS functions. That's supposed to give us a performance boost. And then we're going to do the same thing for units fast. As you can see, again, sales amount and just KEEPFILTERS metrics units. And then I've created another two measures, or another two sets of measures, where I'm adding one more filter condition. So in this one, we're only filtering on account equal dollars. What I want to do is I want to filter for two things. So in this case, I'm going to be calculating sales, which will do the first filter as of dollars. Then I'm going to add another filter that says do the calculation only for the products that are for men's category, men's department. So and I did the same for salesman fast, salesman slow, and unitsman fast and unitsman slow. Okay, so very simple set of functions. The only difference is in slow we're using filter function expression, and then in fast we're using KEEPFILTERS. So now let's see if our performance meets our expectations. The way we're going to gauge our performance is we're going to go into view, and then we're going to open up performance analyzer, and we're going to start recording, and we're going to refresh our visuals. So now what happened, the visuals got refreshed, and we got some metrics back. The problem is that I have already been working with these reports for a little bit, and we can, for example, see that the top left took 303 milliseconds to refresh, which is this grid here, the slow one. So you can see I named them so that it's easier for us to understand which matrix is refreshing and what kind of time. And we see that right now they're all refreshing in about the same period of time. And the reason this is happening, and it's very important to be aware of that when you're doing performance tuning, that Power BI is very good at caching queries. So the first time you run a query, it actually does the hard work figuring out what the answer is. The next time it does it, if it can afford to be lazy and use the cached results, it will. So right now, I'm guessing that the reason this performance is so good is because every time we say, so we can say clear and refresh visuals again, you see these numbers look exactly the same. My guess is that what we're seeing is just the cached results. In order to force Power BI to actually do the hard work and not to give us the cached results, what we need to do is we need to clear the cache. And the way we're going to do it is by using an awesome tool called DAX Studio. So you can Google and find DAX Studio, download and install it. And once you do that, you can click on Connect, pick the Power BI model that you have open. Right now I only have one. You could also connect to Tabular Server, and then click Connect. In my case, I'm already connected. And then here you can find this Clear Cache button. You can hit that button, and what that will do, it will clear the cache in our Power BI model, so that next time I run a query, it will go ahead and do the hard work instead of showing us the cache results. Let's see if that claim is true. I'm going to go ahead and click on Refresh Visuals, and you can see that these numbers are dramatically different. Right, so where before the numbers were in 300 milliseconds, we see the top row of matrix control took 1.5 seconds, and then the bottom one took, in this case, almost 700, in this case, 521. So I'm gonna clear it again, clear the cache again, and then refresh visuals again just to see if we're gonna find any crazy inconsistencies. So in this case, we see that again the top row took over a second to refresh, but now our fast bottom right, which is this matrix here, actually took longer to refresh than bottom left slow, even though in the previous time it was a little bit faster. But the top two matrices here, they both take about the same time, 1.3, 1.4 seconds. So let's do one more test again, just to give it the third, see if the third time is the charm. clear cache, go back to Power BI, refresh visuals, and now again we see that our two top matrix again take about the same amount of time, 1.5, 1.6 seconds, and now we see some benefit in performance from the bottom right. So it looks like bottom left and bottom right kind of go back and forth, and then you can drill into this and actually see the actual query results. So in this case, DAX query was 569 milliseconds and DAX query 353. So why don't we do it one more time and then spend some time analyzing our results. So I'm going to say clear cache, refresh visuals, and so here's what's so let's take a look at what we see. So doesn't appear like in the top row where we only use a measure with one. We see we have unit fast sells fast, or unit slow sells slow. So when we only have one filter, doesn't appear that KEEPFILTERS is providing any performance increases. It appears that every time we've refreshed our model, having cleared the cache, it appears that these two matrices refreshed in about the same amount of time. So the difference is negligible. When we look at the measures that use two filters, so man fast and units man fast, it appears that we had a couple of instances where the left matrix that was supposed to be slow refreshed faster than the right one, but so 1 out of 4, the first time they were virtually the same, and last 2 times the right one was actually a little bit faster, or in this case actually was almost half the time, so here, or third the time. So here DAX query took 341 milliseconds and the slow one took 931 milliseconds. So it appears that in the case when you have several filters applied, at least on our almost billion row data set, we're seeing a little bit of performance improvement in the measures. I'm going to be honest with you, I have tried this several times before, and this is actually the first time where I do see a difference in performance. My computer is running a bunch of other things right now in the background, so who knows, maybe there is some fight for resources, and maybe we're seeing a little bit of benefit. But generally speaking, having played with this for a little bit, for a while rather, I have not seen a dramatic difference between using KEEPFILTERS and filter functions. So there are a couple of things that might be going on. There may be some compiler, I call it double quote, level optimizations, where even though you're using a filter functions in the background, they're replacing filter functions with KEEPFILTERS where possible, and that's why we're seeing very similar performance between the two. Maybe the model is too simple. It seems to me that having almost a billion rows would be the kind of model that would help us highlight the performance advantages of KEEPFILTERS. But we're definitely not seeing a dramatic improvement in performance. But we are seeing some evidence that that performance improvement might be there when our measures are getting a little bit more complicated with having more than one filter in the filter condition. Hope you found this video interesting. Again, I recommend that you guys check out the guidance page for Power BI. There is a lot of interesting articles there, a lot of best practices and commonsensical things. So I'm a big advocate. Definitely go ahead and check it out. And please come back again for more videos. We're trying to post a new video every other day. Thanks. Bye.